Okay, so it's a word problem and diagram, and I mentioned the diagram, lots of word problems have diagrams, but I mention it because it might be a little hard to read this diagram, not just because it's blurry, but just in understanding what they're doing. They explain it, but it still might be tricky. So it says, let line 1 and line 2 denote two non-vertical intersecting lines. Okay, so these are just lines, an orange line and a blue line. Line 1 and line 2. Okay. And let alpha or theta denote the acute angle between them. Now that's shown in the diagram. The theta is right there. Okay. Show that tangent theta is equal to m2 minus m sub 1 plus, or over 1 plus m sub 1 times m sub 2, where m sub 1 and m sub 2 are slopes of L sub 1 and L sub 2 respectively. So that's a lot to say. So we'll go over that part. Hint, use the fact that the tangent of theta sub 1 is equal to m sub 1, and the tangent of theta sub 2 is equal to m sub 2. So this might be like very confusing, you know, just to start this out, but that's why I'm making this video. Hopefully it'll make some sense. So we're going to have to review a little bit of geometry and a little bit of some of the things that we know about slope and things like that. Okay, first of all, a little review. When you have two lines that intersect, they don't have to be right angles. But this angle here and this angle here are equal to each other. Likewise, this angle here is equal to this angle here. Okay? Those are called vertical angles. So it just says if you have two lines that intersect, that's what happens. So I know that my theta is right here. Okay, that's my theta. But it also means that this angle right there, so I'll kind of color it in, that is also theta. Now that's important because up at the top, I just have these lines going off, right? I don't have a triangle. I do have a triangle. It's not a right triangle, but I see a triangle right here. And I'm going to use some of that information, but I'm also going to do a little bit of review. Okay, so we have, let's see, this is theta sub 1 right here, okay? And then this over here, that's theta sub 2, okay? So there's my triangle with the three angles, right? Theta, theta sub 1, and theta sub 2. Well, no, I take that back. It's a triangle with theta sub 1 and theta, and then my theta sub 2 is kind of on the other side. So I'm going to show where that comes from. Let's see how, I'm running out of colors. Okay, this, I think I can do it in red. This angle right here, let's call that theta sub 3, okay? Now, there's a lot in this diagram. Now let's look at this. If I take the three angles of my triangle, so I have the triangle drawn in black. So if I take theta plus theta sub 1 plus theta sub 3, that has to equal 180 degrees, right? Those are three triangles, or three angles of the triangle, and it has to equal 180. I also know that theta sub 3 plus theta sub 2, that also equals 180. Right? Because those are supplementary angles. This one here and this one here, they're on the x-axis and they're supplementary, so they have to add up to 180. Okay, so now I'm going to use those two ideas together to say theta plus theta sub 1 plus theta sub 3 is equal to theta sub 3 plus theta sub 2. Okay, and you could have a better way of doing this. This is just the way I'm doing it. All right, you can subtract theta sub 3 from both sides. We didn't need that. So theta is going to equal theta sub 2 minus theta sub 1. Now that's important. That's like a little golden nugget here. It's not the answer, but it's a golden nugget. Okay, why? So I'm trying to find the tangent of theta, okay? So now I know theta is theta sub 2 minus theta sub 1. Now I can use like my tangent formula, right? Okay. So let's see, where can I write that? Tangent theta is going to equal tangent theta sub 2 minus theta sub 1. Now I'm going to apply that difference formula for tangent. So it's going to be tangent theta sub 2 minus tangent theta sub 1 over 1 plus tangent theta sub 2 tangent theta sub 1. Okay, so that's the formulas that we've been working on and applying that. Okay, now you can go to the hint, but I always like to check the hints to make sure that it makes sense to me. Okay, so on my diagram, this might be hard to draw, there's a point here, right, and a point here on the triangle. That distance, if you think about going up from one point and over to the other point, that's the slope, right? Rise over run. Rise over run. That is the slope. So I don't know the last time you did this, but that forms a right triangle, correct? Okay, so you can think about that in terms of the tangent, right? So think about this as the opposite side, and this as the, well, let's see, maybe I want to do it the other way. No, I can do it this way. And the adjacent side. And then if I draw like a little perpendicular here, then that slope of that line is equal to the tangent of the angle, right? Okay, so this was my theta sub 1 right here. That was my theta sub 1. And the tangent of theta sub 1 would equal the opposite side over the adjacent side, which is the rise over the run, or the slope, sub 1, right? Okay, so it's the slope for that line. So tangent theta sub 1 is equal to m sub 1. And you can do the same thing with tangent 2. But this was all in the hint right here. I was just trying to explain the hint, like why we can say that. Okay, so that's great news now. The tangents can be replaced with the slopes. And so we're going to have m sub 2 minus m sub 1 over 1 plus, we can write m sub 2, m sub 1. They might have those switched, but that's going to be the same thing as right here. Okay, so all of this is going to be the same thing. Now, multiplication is commutative, so let me rewrite it. M sub 2 minus m sub 1 over 1 plus m sub 1, m sub 2. Okay, there, we showed that that is the tangent of theta. Tangent theta. Okay, that comes from there. All right, so that was a fun problem, but I wanted to go over some of that geometry and maybe some things that we've forgotten, just to review, refresh. Okay,